Hello everyone, welcome to another video lesson. Today we will discuss the fundamentals of maintenance. In the agenda for today, we will discuss things like failure mechanism, failure mode, what is the distinction between the failure mode and the failure mechanism, what is failure itself, and what is maintenance. Other concepts that are important to understand maintenance and failure are, for instance, operational conditions, or functionability or function requirements. We will also talk about that. In the end, this lesson is to give you a terminology that you can use whenever you are talking about maintenance. And one of the first things that we will talk about is the stakeholders of maintenance. So who is affected and who influences maintenance overall. As stakeholders of maintenance, we have different types of organizations, such as the suppliers or the manufacturers. We have the original equipment manufacturer, which is organizations such as Embraer or Boeing or Airbus that actually put everything together to construct a ready-to-fly aircraft. And then we have the airlines, and if you consider the military customers, we have also the customers that buy planes for military purposes. We also have the airports. They are involved in maintenance because whenever you have line maintenance or maintenance in the warehouses of the airport is involved. And of course you also have the regulatory bodies, the regulatory parties that make sure that everything goes according to plan and that everything is well certified and regulated. In addition to these organizations, we also have the MROs, the Manufacturing, Repair and Operations Independent Parties. So this is independent parties that perform maintenance. But maintenance can be performed in different places, such as, for instance, by the supplier, sometimes by the OEM, which is not so often. And also the airlines can take that responsibility, as well as the military customers. After we have laid out the stakeholders, who is who and who does who, it's important to understand the goals and the objectives of maintenance. So all these people are involved in maintenance, but what does maintenance aims for? As we have said previously in another video, maintenance is a continuous process of operational optimization where you try to balance the costs and the benefits. And in that respect, you have three goals in mind. One is safety, the other is availability, and of course the optimization itself. So safety means that you always target airworthiness state. Availability means that you try to make the fleet or the aircraft being used in an optimal utilization rate. And of course, optimizing the costs means that you have the lowest possible costs given the highest possible benefits. If you are curious about what does this costs and benefits mean, well, costs are, for example, the costs that it takes to have physical and human resources to do a maintenance task, but it's not only that. So the time taken to complete and to plan and to schedule maintenance strategies is also considered in the costs optimization. You also have logistic costs because sometimes you have to take spare parts from one side to the other. And of course, if you perform your maintenance well, everything is going well. But if you don't do that, you will have less performance, less efficiency, and this can, for instance, mean more pollution and less sustainability. In terms of benefits, we have the benefit of added performance if the maintenance is well performed. We have safety, of course. We don't want the parts to fail while in the air. And overall, we can promote a better customer experience because less disturbance to the scheduling of the customers, of the clients incurred. A failure mechanism is something that happens way before failure, and it's important to talk about it because sometimes people think that the failure mechanism is the failure while it's not quite the same thing. So, for instance, corrosion. Corrosion starts to happen, and at some point it gets to some degree that you can consider it to be failure. But the failure mechanism itself, the corrosion, happens often in many different equipments, not just once, not just only one, and it ultimately leads to failure of the equipment. These failure mechanisms, these irreversible changes, can take by many names and can take many forms, such as, for instance, corrosion, as we talked about, wear, so with time things wear out, accumulation of deformations, distortion, due to high temperatures, overheating, fatigue, and sometimes even the diffusion of one material into another. So all of these can be considered failure mechanisms. They lead to failure, but they're not exactly failure. They're more the process of degradation. A failure mechanism is very different from a failure mode, in the sense that the failure mode is how the failure happens, while the failure mechanism is what happens before the failure mode, before the failure. But before we go into depth into what is a failure mode, I would like to talk about performance requirements and operational conditions. These are buzzwords in maintenance that everyone talks about, but sometimes when you are new to the field, it's hard to understand what they're talking about. So a performance requirement is quite easy to understand. It's a requirement that you define at the design stage that the equipment or the system has to meet. In other words, it's the extent to which a function of the system has to be executed. And it's usually measured in quantities or accuracy or coverage or by any other quantifiable mean. I give 3 examples of performance requirements for different equipment. So for an engine, you can say that the engine must deliver the maximum thrust of 10,000 pounds. You can also say that the bypass turbofan must have a speed higher than a certain limit. Or you can see that the fuel consumption of the turbofan must be no more than a certain value. These are all performance requirements. Why? Because once they are broken below or above, according to the performance requirements, you no longer can say that the system is functioning properly, and you can consider it to be a failure. But whenever you are talking about the performance requirements, you have to define the environment or the operation boundaries that the system is operating within. So, for example, if you said, going back to the performance requirement of the 10,000 pounds, you have to say that this is at sea level, Mach number 0.3. Why is that the operational conditions is so important? Well, it's because a slight change in operational condition, a slight change in speed, for example, change completely the performance and hence the degradation boundaries of the system. The operational conditions are very important because they can mask the degradation signals. So for instance, you see here several signals of the same engine over the course of a lifetime of the engine, and you can see that with some noise you can see a signature, a trajectory that is exponential. And this is very important to determine failure and to diagnose failure and to predict failure ahead of time. But when you have several conditions mixed, so when you have, for instance, the engine going cruise, climb, descend, and so on, over several cycles, you get to see that there's no clear pattern in the degradation signals. And this is because the cooperational conditions kind of mask the deterioration signature. Understanding what are the operational conditions and disentangling the effects of the operational conditions can lead to a better understanding of the ultimate degradation signals that the system is subject to. It's not easy to do. There are several techniques such as clustering, different kinds of clusterings that can be applied. But the important is to know that the operational conditions have an effect on the degradation signals. Now we are ready to talk about failure. Failure is no more than the inability of the system, the incapacity of the system to meet the minimum acceptable set of functional requirements, of performance requirements, under some predefined operational conditions, environmental and operational conditions. So what does this mean? This means that if you have certain requirements, if at least one of them is not met under certain conditions, then you can say for sure that you have a failure. Going back to the failure mechanism, we have now the concept of failure mode. So after the failure mechanism comes failure, which can express itself in different failure modes. So the failure mode is the way the system, the unit, fails. So for example, you have a bearing has different failure modes, and the more complex a system is, the more number of failure modes it has. So for instance, a bearing can fail when a ball gets out of the round, when the races get grooved, or when things get pitted. Other failure modes are possible, but these three just give you a notion of what is a failure mode. With all of this said, we can now go to the maintenance definition. Maintenance definition is that we agreed on is that maintenance is a continuous process of operational optimization that seeks to find a balance and equilibrium between the costs and the benefits of prescribing a maintenance action, which can be inspection, repair, renewal, replacement, or other. To operate an engineering system in a state that is considerable good, where you meet all the performance requirements under certain operational conditions. That is all for today. So we defined, listed and distinguished the fundamental concepts of maintenance, such as what is failure, what is a failure mechanism, what is a failure mode, what is a functional requirement, what is an operational condition, what is maintenance, and we listed the stakeholders, the main goals of maintenance. So we talked about different things to make sure that you fully understand the context and the environment where maintenance happens in the context of aeronautics. I hope you have liked the lesson. That's all for today, and see you next video lesson.